Mixing circuits from two different electrical panels in the same conduit is a significant electrical safety hazard. You cannot connect circuits from two different electrical panels in the same conduit because it can create an unintended electrical pathway between the two panels. This situation can potentially lead to overload, short circuits, or electrical fires, posing a serious risk to property and life. The National Electrical Code, NEC, prohibits connecting circuits from different panels in the same conduit. NEC Section 300.3 B states that conductors of different systems, circuits, and voltages shall not occupy the same raceway, cable, or enclosure. This code requirement is in place to prevent the dangers associated with mixing circuits from different sources. There are several alternative solutions to consider to ensure electrical safety and code compliance. Firstly, installing separate conduits for each circuit coming from the different panels is the safest and most code-compliant solution. This approach ensures complete physical separation of the circuits, preventing any electrical crossover or interference. Secondly, using a junction box with a barrier to separate the two circuits is another option. This allows you to connect both circuits to the same box, but the barrier prevents any electrical crossover. However, this solution is not ideal as it does not provide complete physical separation of the circuits and might not meet all code requirements in all jurisdictions. Thirdly, installing a sub-panel off of one of the existing panels is a more comprehensive solution. Run a feeder conduit from the main panel to the sub-panel. Then connect the E-light to a circuit within the sub-panel. This solution provides complete isolation of the circuits and allows for better management of electrical loads. Considering the potential safety hazards and code violations, the safest and most code-compliant solution is to install separate conduits for each circuit coming from the different panels. This ensures that each circuit is isolated and protected, minimizing the risk of electrical problems. When working with electrical systems, always prioritize safety and adhere to the NEC and local electrical codes. If you're unsure about any aspect of the installation, consult with a qualified electrician to ensure that the work is done safely and correctly. Understanding the NEC is critical for ensuring safe electrical installations. Here's a deeper look into why Section 300.3 B is so important. The primary reason for not mixing circuits from different systems, circuits, and voltages within the same raceway, cable, or enclosure is to prevent insulation breakdown and subsequent electrical faults. When conductors carrying different voltages or belonging to different systems are placed in close proximity without adequate insulation, the risk of arcing and short circuits increases. The NEC aims to mitigate these risks through its regulations. The term raceway refers to any channel designed and used expressly for holding wires, cables, or bus bars. Raceways can be metal or non-metallic and include conduits, electrical metallic tubing, and cable trays. The purpose of a raceway is to protect the conductors from physical damage and environmental factors. Cables are assemblies of two or more conductors within an overall jacket or sheathing. Common types of cables include non-metallic sheath cable, NM cable or Romex, armored cable, AC cable or BX, and metal-clad cable, MC cable. Enclosures are boxes, cabinets, or other containers designed to house electrical components such as splices, terminations, and devices. Enclosures provide protection from physical damage, environmental factors, and accidental contact with live parts. Section 300.3 B of the NEC addresses conductors of different systems, circuits, and voltages. Different systems refer to electrical systems operating at different voltage levels or having different grounding configurations. For example, a 120-volt system and a 277-volt system are considered different systems. Different circuits refer to individual pathways for electrical current within a system. Each circuit is typically protected by a circuit breaker or fuse. Different voltages refer to conductors operating at different voltage levels. For example, a 120-volt circuit and a 240-volt circuit are considered different voltages. The NEC provides exceptions to the general rule in Section 300.3 B, allowing certain combinations of conductors in the same raceway, cable, or enclosure under specific conditions. One common exception is for low-voltage control, signal, and communications circuits. These circuits are often permitted to be installed in the same raceway as power conductors, provided that they are insulated for the highest voltage present in the raceway and meet other specific requirements. Another exception applies to conductors of different circuits within the same system, such as multiple branch circuits serving different loads in a building. These circuits are generally permitted to be installed in the same raceway, provided that they are properly insulated and protected. Proper insulation is critical for preventing electrical faults when conductors of different systems, circuits, and voltages are installed in close proximity. Conductors must be insulated for the highest voltage present in the raceway cable or enclosure. The insulation must be suitable for the operating temperature and environmental conditions. Grounding is another important consideration when working with electrical systems. The NEC requires that all metal raceways, cables, and enclosures be properly grounded to provide a low impedance path for fault current. This helps to protect against electric shock and minimize the risk of electrical fires. When installing conductors of different systems, circuits, and voltages in the same raceway, cable, or enclosure, it is important to follow the NEC requirements for separation and identification. Conductors must be arranged and identified in a manner that prevents confusion and minimizes the risk of accidental contact. In addition to the NEC requirements, local electrical codes may also impose additional restrictions on the installation of conductors of different systems, circuits, and voltages. It is important to check with the local electrical inspector to ensure compliance with all applicable codes and regulations. Violating the NEC requirements for the installation of conductors of different systems, circuits, and voltages can result in serious consequences, including electrical shock, fire, and property damage. It is important to follow the NEC and local electrical codes carefully to ensure the safety of people and property. Here are some additional details about the alternative solutions mentioned earlier. Installing separate conduits for each circuit provides the highest level of safety and isolation. Each circuit is contained within its own dedicated raceway, preventing any possibility of electrical interference or faults. When installing separate conduits, it is important to ensure that the conduits are properly sized to accommodate the conductors and that they are installed in accordance with the NEC requirements. Using a junction box with a barrier can provide a degree of separation between circuits, but it is not as effective as installing separate conduits. The barrier helps to prevent accidental contact between conductors, but it does not eliminate the possibility of electrical interference or faults. When using a junction box with a barrier, it is important to ensure that the barrier is properly installed and that the conductors are arranged in a manner that minimizes the risk of contact. Installing a sub-panel provides a more comprehensive solution for separating circuits and managing electrical loads. A sub-panel is a separate electrical panel that is fed from the main panel. It allows you to create dedicated circuits for specific loads, such as lighting, appliances, and equipment. When installing a sub-panel, it is important to ensure that the feeder conductors are properly sized and protected and that the sub-panel is installed in accordance with the NEC requirements. When working with electrical systems, it is always important to follow safe work practices. Always to energize circuits before working on them and use appropriate personal protective equipment, PPE, such as gloves and eye protection. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work. Ignoring these safety measures can lead to severe injuries or death. Remember, electricity is dangerous and should always be treated with respect. Proper planning is an important part of any electrical project. Take the time to plan your work carefully and to identify any potential hazards. This will help you to avoid accidents and ensure that the work is done safely and correctly. If you have any questions about electrical safety or the NEC requirements, consult with a qualified electrician or electrical inspector. They can provide you with the information and guidance you need to ensure that your electrical work is done safely and in compliance with all applicable codes and regulations. Consider the potential for future expansion when designing your electrical system. Install conduits and panels that are large enough to accommodate future circuits and loads. This will save you time and money in the long run. Label all circuits and panels clearly. This will make it easier to identify and troubleshoot electrical problems in the future. Keep accurate records of all electrical work that you perform. This will be helpful for future maintenance and repairs. Educate yourself about electrical safety. The more you know about electricity, the safer you will be. Attend electrical safety training courses and read books and articles about electrical safety. Be aware of the signs of electrical hazards, such as frayed wires, damaged insulation, and sparking outlets. If you see any of these signs, take action to correct the problem immediately. Never overload circuits. Overloading a circuit can cause the wires to overheat and start a fire. Use a circuit breaker finder to identify the correct circuit breaker for each outlet and appliance. This will help you to avoid overloading circuits. Use extension cords safely. Never use extension cords as a permanent wiring solution. If you need more outlets, install additional outlets or circuits. Inspect extension cords regularly for damage. Replace damaged extension cords immediately. Keep electrical cords away from water and heat. Water and heat can damage electrical cords and create a shock hazard. Unplug appliances when you are not using them. This will save energy and reduce the risk of electrical shock. Install ground fault circuit interrupters (GFCIs) in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to protect against electric shock. Test GFCIs regularly to ensure that they are working properly. Hire a qualified electrician to perform all electrical work. Electrical work is dangerous and should only be performed by qualified professionals. Never attempt to repair electrical equipment unless you are qualified to do so. Electrical equipment contains hazardous voltages and can cause serious injury or death. Be sure that any electrical equipment used is safety certified. Check for product safety certification marks that show the equipment has been tested to meet safety standards. Arc fault circuit interrupters of size are also an important safety device. They provide protection against electrical fires caused by arcing faults. Consider using surge protectors to protect sensitive electronic equipment from power surges. Power surges can damage or destroy electronic equipment. Remember to have regular electrical inspections. Schedule regular electrical inspections to identify and correct any potential electrical hazards. In summary, remember these key points about electrical safety and working with circuits from different panels. Firstly, never mix circuits from different electrical panels in the same conduit. Secondly, always adhere to the NEC and local electrical codes. Thirdly, prioritize safety and use appropriate PPE. Fourthly, when in doubt, consult with a qualified electrician. By following these guidelines, you can help to ensure a safe and reliable electrical system.